Okay, so moving on to our second example. Notice I entered the answers we pulled from Minitab up here, and I'm going to save this document and circulate it with my video links. Um, Second example, um, we are vaccinating cattle. So cattle are vaccinated. The probability of a reaction, of a particular cow having a reaction to the vaccination is 0.005. 0.0005. Okay, so threes after the decimal point, 3 zeros, then a 5. We vaccinate 500,000 head of cattle. Some of them are going to have a reaction. So let's approximate the probability that less than 280 have a reaction. Okay, why is it approximate here? Well, because we could find the exact probability. This is a binomial distribution question. We have an experiment. Probability of a reaction is 0.0005. We were repeating that trial 500,000 times. The binomial distribution will tell you what is the probability that 280 or less have a reaction. But if we use the binomial distribution formula could tell you the probability that 280 have a reaction, or 279, or 278, or 277. If we wanted to find the probability that less than 280 had a reaction, we'd have to do the binomial distribution formula for every number from 0 up to 280, or maybe up to 279, since it says probability that less than 280 have a reaction. That would be a pain to do by hand. Minitab could do it. We could just ask Minitab to do it, and it would do it fine. It can do all 280 of those computations fine. But once you're repeating a binomial question a lot of times, then the normal distribution approximates it pretty well. Now, that's what we sort of talked about when we first had the normal distribution. So let's use the normal distribution to approximate this. We need to know what the mean and the standard deviation are going to be. So those come from the binomial distribution formula for formulas for mean, expected value, and standard deviation. So what's the expected value? Well, we have 500,000 times we're repeating this trial. There's a 0.0005 chance of a reaction happening. So we multiply those and we get 250. Okay, so we're expecting 250 cattle to have a reaction. Of course, that's just like the average. We wouldn't expect to hit 250 exactly when there's that many possible numbers that are nearby that it could be. Okay, what about the variance? The variance, you sort of need to remember the formula. It's 500,000 times the probability of a hit times the probability of a miss. So that's 9995. Okay, that gives us the variance, and this comes out to 249.9. We do need to know the standard deviation. So you're not going to be able to see it on your screen, but I'm pulling up a calculator, and I'm going to take the square root of 249.9, and it comes out about 15.8. So our standard deviation is equal to the square root of 249.9. Come on, there you go. 249.9. And let's get a few decimal points. 15.8082. 15.8082. Okay, so these are the two numbers we need to put into Minitab. Let me flip over to Minitab. Okay, switch my screen. Let's bring up our normal distribution plot. I said my mean was 250, and my standard deviation was 15.8082. Double check that, 15.8082. Okay, so that was my expected value and variance from my binomial distribution, and I'm going to use the normal distribution to approximate that. And so we could have just chosen binomial and put everything in here, and maybe we'll do that after this is over. But let's use our approximation with the normal distribution. We wanted an x value. We wanted to know the probability that we got less than 280. Now, I did say that with the binomial, it really should be 279, but the way the question was worded, I think we're expected to put 280. I pulled this question out of the textbook. So 280 is the cutoff that they mentioned. Less than in the bell means the left tail. And so we're going to hit OK and see what we get. So this comes out to 97%, basically. So 97 or 0.9711. Okay, now let's see if we can do that with binomial. So this isn't what we were asked to do, but I just want to see if we can do this with binomial. So I flipped the distribution, which has been normal every time we've done one of these questions. I flipped it to binomial, and we're doing 500,000 trials of this. I'm not putting a comma in. I don't think Minitab will like the comma. And the event probability is 0.0005. X value 280. We're doing a left tail. Let's see what the binomial version gives us. So this gave us 0.9714. Remember, we got 9711. This is 9714. Very close. Okay, so the normal distribution gave us a good approximation. Minitab can handle doing the binomial and adding up all of these bars in the bar chart. We couldn't do that by hand. But the normal distribution, that's, we kind of can do that by hand. I mean, we can't do these integrals. We need software to do that. But if we were doing this on like a calculator, like a TI-84, we could not do the binomial one, but we can do the normal distribution one. Okay, so those are my examples for today. I'm going to add a couple homework problems to the document that has my notes and the links to the videos. And I know that some of you might not have your textbook. I don't know, depending on if you're able to get onto campus or whatever, you're supposed to move out of your dorm. But I'm not going to assume that everybody has their textbook with them. So I'll type up the problems and the answers and attach those to the homework sheet. And I'm not going to be giving any quizzes this week while I figure out the best way to do that. I was originally planning D2L, but I don't know if D2L is reliable. So next week I'll start actually like asking for some responses to questions that we will use for your quiz score. Okay, so we'll stop this video, and that'll be it for the videos for Wednesday, March 25th.